Hi, my name is Jessica, and today we're going to discuss the pathway and mechanism of aspirin. Aspirin is known to have a wide range of effects, including relieving inflammation, fever, pain, and blood clotting, and we're going to learn how this works today. Here's the structure of aspirin. Aspirin, also known as acetyl salicylic acid, or ASA, is a nonsteroidal anti-inflammatory drug that blocks the family of enzymes known as cyclooxygenases, otherwise known as COX. Aspirin targets and blocks two enzymes in the cyclooxygenase family, COX-1 and COX-2. Aspirin irreversibly inhibits COX-1 and modifies the enzymatic activity of COX-2. These enzymes have similar structures but different functions. Both enzymes generate prostaglandins from the fatty acid arachidonic acid. Prostaglandins are potent, irritating substances that increase the sensitivity of pain receptors. Prostaglandins from COX-2 are associated with pain, inflammation, and fever, while prostaglandins from COX-1 support platelet aggregation, gastrointestinal mucosal integrity, and renal function. The acetyl group on aspirin is hydrolyzed and then bonded to the alcohol group of serine as an ester. When this happens, it blocks the channel in the COX enzyme, and arachidonic acid cannot enter the active site, therefore preventing the conversion to prostaglandins. Aspirin covalently modifies the COX-2 enzyme through acetylation of SER516 near its active site, which prevents proper binding of the native substrate, leading to an irreversible inhibition. Aspirin blocks COX-1 by binding to SER530 in the same way that it binds to SER516, but the active site of COX-2 is slightly larger than the active site of COX-1. COX-2 triggers immune responses and swelling in response to infection. By inhibiting the ability of COX-2 to form pro-inflammatory products such as prostaglandins, the enzyme's activity is converted from a prostaglandin-forming cyclooxygenase to a lipoxygenase-like enzyme. Aspirin-treated COX-2 metabolizes a variety of polyunsaturated fatty acids to hydroperoxy products, which are then further metabolized to specialized pro-resolving mediators such as the aspirin-triggered lipoxins, aspirin-triggered resolvins, and aspirin-triggered myrisins. These mediators possess potent anti-inflammatory activity, and it is proposed that this aspirin-triggered transition of COX-2 from cyclooxygenase to lipoxygenase activity contributes to the anti-inflammatory effects of aspirin. COX-1 enzymes are the key enzymes in thromboxane A2, which is also known as TXA2 generation. Thromboxane TXA2 causes platelets to clump together over the vessel tear to facilitate repair when blood vessels are damaged. The aggregation of platelets results in a clot, which stops bleeding and aids to repair the damaged blood vessel. Aspirin inhibits COX-1 and therefore TXA2, which reduces the ability of platelets to accumulate. This is why aspirin is known as a blood thinner. The inhibition of platelet aggregation by ASA occurs because of its interference with thromboxane A2 and platelets caused by the COX-1 inhibition. Thromboxane A2 is an important lipid responsible for platelet aggregation, and it can lead to clot formation and the future risk of heart attack or stroke. Now that I've talked so much about how aspirin prevents the production of prostaglandins, I will now further explain what prostaglandins are. Prostaglandins are a group of active lipid compounds and are found in almost every tissue in humans. Prostaglandins and thromboxane A2 are considered prostanoids and are formed when arachidonic acid, which is a 20-carbon unsaturated fatty acid, is released from the plasma membrane by phospholipases and then further metabolized by COX. Prostaglandins act as vasodilators and inhibit the aggregation of blood platelets. Through their role in the vasodilation, prostaglandins are involved in inflammation. When the body experiences stress, trauma, or infection, COX-2 is activated and produces extra prostaglandins, which help the body respond to the injury. Prostaglandins are one of the more potent mediators that cause increased blood flow and chemotaxis, and chemotaxis is when chemical signals summon white blood cells. They are our body's response to harmful agents and will be continuously produced and add to the inflammatory process as long as these harmful agents are present. Once aspirin blocks COX enzymes from working, prostaglandin synthesis becomes blocked and results in temporary reduction of prostaglandin induced inflammation until normal COX activity resumes.